How are you, my friends? This is Calculus 1 solved questions about linear approximation and differentials. Question number 1, use the linear approximation formula to approximate 4th root of 80 cubed. You can look at lecture 15, actually, in Calculus 1, where we have the summary here on this slide. If we need to approximate linearly, it will be f of x at the number x, approximately f of a plus f prime of a times x minus a. So let's start here. We need to approximate 80 to the power 3 over 4. So we can construct or consider a function. It looks like x to the power 3 over 4. So if I choose a to be 81, f of 81, it will be 3 to the power 4 to the power 1 over 4 to the power 3. So we can cancel this 4. So it will be 3 cubed equals 27. So if I replace 81 in the function, the image will be 27. Directly, we need the derivative also. F prime of x will be 3 over 4, x to the power 3 over 4 minus 1, which will be minus 1 over 4. So we can write it as 3 divided by 4 times 4th root of x. Now x is 80, and 81 is very close to 80 actually. So f of 80 will be f of a. So f of 81 we have found already 27 plus f prime of 81. So I can replace 81 in the derivative, 3 divided by 4 times 4th root of 81 times x minus a. So 80 minus 81. If you simplify these simple numbers, you will get the fraction 107 divided by 4. This is the approximation. Or if you use a calculator, it will be 26.75. So 4th root of 80 cubed will be approximately 26.75. Now in this question, we need to find the linear approximation to the function itself. Let's find a linear function, straight line, approximating this function f of x is equal to ln of x plus 1. This is a logarithmic function to the base e, near the point a equals 0. Now this is the formula. L of x will be approximately f of a plus f prime of a times x minus a. You can see that in lecture 15. Let's start here. We have the function f of x is equal ln of x plus 1. We have the x a equal to 0, so we find the image. F of 0 will be ln of 1, which is also 0. The derivative will be u prime over u. Remember the formula for ln of u. So the derivative will be 1 over x plus 1. The linear approximation will be L of x. We are finding a function now, linear function, f of 0, which is 0, plus f prime of 0. Put 0 in f prime will be 1 over 0 plus 1, which is 1, times x minus a. So x minus a will be all x. So now to linearly approximate the function ln of x plus 1, it will be x, which is a linear function near 0. Use linear approximation to estimate cosine 43 degrees. We have done similar in the lecture, sine 61, I think, degrees. So this is very similar, cosine 43 degrees. So we need to approximate this number here. So let's consider a function cosine of the x. 43 degrees, let's choose an angle close, maybe pi over 4 is 45 degrees, but we need all radians. F of pi over 4, we know it's square root of 2 over 2. Let's find the derivative of the cosine of the x, which is minus sine of the x. Now x will be 43 degrees. The linear approximation will be L of x, f of pi over 4 plus f prime of pi over 4, x minus pi over 4. Now x, we have to change this 43 degrees into radians, so we multiply by pi over 180. Just put the numbers there. cosine of pi over 4 square root of 2 over 2. This one sine also pi over 4 will be square root of 2 over 2 multiplied by all this here. You find the LCD 180, it will be minus 2 pi. Cancel this 2. You can say cosine 43 degrees will be approximately 90 plus pi multiplied by square root of 2 divided by 180, which is 0.7318. Question number 4, we have three functions, y of the x, we have t of the x, we have m of the x. Three functions, we need dy, the differential, dt, and dm. So that's easy. The first one is a product, x cubed. You see, this one is x cubed times e to the power minus 2. This is the product rule, just to remind you, u prime v plus v prime u. So you know how to do that. So we need dy, the derivative here, times dx. You can take e to the power minus 2x as a common factor. Now here we have t is the function sine of 2x, cosine of 2x. Let's find dt. So it will be, this is also product, sine of 2x, cosine of 2x. Use the same rule here. So simple. The derivative of the first will be 2 cosine of 2x. Leave this one. And then the minus, not from the formula. The formula, it has a plus. Now the minus coming from the derivative of the cosine of 2x, it will be minus 2 sine of 2x times this sine of 2x. So you can take here 2 common factor. You have cosine squared of 2x minus sine squared of 2x. You can use this double angle formula. This is from pre-calculus, lecture number 23. Cosine squared of u minus sine squared of u will be cosine of 2u. So we have here cosine squared of 2x. This is like u minus sine squared of 2x, also the same u. And this 2 is a common factor, remember? Leave it outside here. So this becomes cosine 2 of the u, and the u itself is 2x. So it will be 2 cosine of 4x dx. This is dt, 2 cosine of 4x times dx. Now this is function m, x minus square root of 4 minus x cubed. This is not a product, it's only subtraction. So dm will be the derivative of the x is 1 minus the 1 over 2 square root of 4 minus x cubed times the derivative of the inside here. The 0 is the derivative of the 4 minus 3x squared. Simplify that. So dm is equal all this fraction times dx. Now, for more questions on linear approximation and differentials, you can see lecture number 15, or for more questions on Calculus 1 in general, you can see Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.